All right, everything's working. Thank goodness. Okay, thank you so much for having me here. My name is Larene, and today I am talking about practical accessibility testing for data visualizations. Mouthful. I'm currently at Canva, but this is stuff that I've been working on in my spare time. But I am the engineering lead for accessibility, the accessibility team at Canva. I just joined a couple of months ago, but these things are unrelated at the moment. So one of my personal goals is to make accessibility more accessible for people who work in technology. Hopefully that's you folks. And I also like to kind of apply accessibility to uncharted territory. Got a pun in there. But I just wanted to ask the audience, who has heard of accessibility before? A few folks. And whose company is doing accessibility that you know of? Three. Okay, fantastic. That's awesome. Kudos to you. Hopefully this helps inspire a few more companies to maybe start to think about it a bit more. Okay, and if you'd like to take a quick QR code or whatever of the slides, I'll also share this QR code again at the end. There are a lot of resources, a lot of links and stuff in here. Today, half an hour is definitely too short to be able to kind of teach you everything you need to know about it, but today is kind of just a bit of a tour, a bit of a demo, sneak treat. Sneak preview, that's what I was trying to say. Treats, I think I'm very hungry. I missed morning tea. These slides do have some accessibility issues. If they didn't, I wouldn't need to work at the job at Canva. Just kidding. I love my team. They've done an incredible amount of work to improve accessibility of the Canva product in a really, really small amount of time. But we still have a ways to go. This talk is actually based on a chapter that I wrote last year with a bunch of folks from that mentioned data viz accessibility kind of unofficial working group. And it's essentially just this talk in written form. But I wanted to start with a bit of a story. My dad is a machine learning engineer. He's 84. He is currently doing, as his retirement job, data entry for music since it began. Like 1911 is kind of big band is what he's working on at the moment. So he'll find some MP3s and kind of annotate them with lots of interesting metadata about that particular song. He uses Windows XP. He also is a user of something called a screen reader, which reads the screen aloud, and he's also blind. And so on the slide here, I have a bit of the information that he's using for his research. It's a scanned page of a bunch of musical information that's typed up and is something he's using, which is a PDF, to kind of fill in his music archive information. I don't know a whole lot about music, but this is what that scan of the page looks like to him. It's just a picture, and no alternative text or no kind of text is supplied. And he uses Windows XP because most of the apps on kind of new stuff, new OSs and are not accessible. New software is not accessible, related to music archiving is not accessible to him that he's found, and also most new websites that have musical archive information are not built very accessibly. The reason why I call him a machine learning engineer is because we used OCR library, or optical character recognition library, to kind of try and convert that PDF book of scanned images into text so that he can actually find the information and do his archiving. But we found that OCR and typewriters are not friends, which is very surprising because, I didn't think it would be that hard to solve. I'm sure someone here would solve it really quickly. But it's about 90% accurate, and he's doing the kind of extra machine learning bit of like he can recognize that maybe a B is supposed to be an 8 and an I is supposed to be a 1, and so on and so forth. Thought I'd share a bit of that story. But what's really exciting in AI and ML is that it is a really exciting time for accessibility with LLMs and things like that. There's an app called Be My Eyes where blind people can upload a picture and ask random strangers on the internet to describe what is in that picture for them. Really useful for things like medication, expiry dates, asking if an outfit is the one they think it is. Obvious privacy concerns, but now with GPT-4 and OpenAI, blind folks are able to request a description without having to kind of get a stranger involved. So really, really exciting time. But a bit of a word of warning. We're a room of smart and helpful people, and we really want to solve problems which help real people, which is great. But I just wanted to include a gentle reminder that we need to make sure that we involve the people that we are solving the problem for. This is a great article written by, I don't know who, but a lot of inventions that have come up kind of over the last however many years solves a problem for disabled folks, but didn't actually involve any of those impacted disabled folks in the invention. And then most of the time it was too expensive for them to buy anyway. So yeah, man solves problem no disabled person actually has with unaffordable invention. So just a reminder, there's a disability advocacy saying nothing about us without us, and this is the reason why I'm giving this talk. We not only need to kind of include folks with disabilities in terms of testing our product along the way, but in data engineering profession itself, making sure that data viz is accessible is just one small step towards better inclusion overall. And someone I know who uses a wheelchair is really dreading self-driving car technology becoming the norm. And a reason for this is they're worried that if the car has to make a decision between hitting, they might not be able to detect like a human who's sitting in a wheelchair. And I've done some computer vision courses in the past, and knowing those data sets, unfortunately I was like, those worries are not too unfounded, but that's all right. We'll make sure that we do all the ethics and responsible engineering and all that. So, but back to data viz. Hey, look at my awesome chart. So COVID-19, the presidential election, like 2020 era, a lot of charts on the internet were being shared with like critical health information, but to a lot of blind folks, it just sounded like this. The screen reader would just say image, and there was no description included. So accessibility is not just about blindness. So I wanted to kind of do a bit of a practical hands-on exercise today with everybody. Let's test and fix an inaccessible chart, and we'll learn some things about accessibility and disability along the way. But for those who might not have heard of accessibility before, it's about how it's all about how to design, build, and test our software products, our technology, our services, so that it's usable by people with disabilities in an equitable way. So same equivalent experience for everybody. So I'm not a professional accessibility auditor. I absolutely recommend scheduling accessibility audits if you have any software products that are meant to be inclusive of everybody. They'll find all the bugs and they're really helpful at helping you fix them. But this knowledge will get you a long way towards building more inclusive charts. And all these tips will help people who might have blindness, low vision, color vision deficiencies, cognitive disabilities such as ADHD, learning disabilities, and also things like low data literacy, which when I read a paper on it is actually much more prevalent than I expected. And also maybe people who don't speak the same language that the chart is in, so an English second language speaker and whatnot if the chart's in English. And so I kind of made a big checklist and then split it up into 4 categories of testing. We've got content, visual, non-visual, and interactive. And we're gonna have to speed through it, so I don't think we would even get through the interactive bit alone in half an hour. So, but that's all in the article I've written, which I'll link at the end. But at least a lot of accessibility problems can be solved by assessing the content, looking at visual accessibility, and also looking at non-visual accessibility or supporting screen readers and assistive technologies. All right. How's that sound? Good. Okay, so let's start with a content testing checklist. Now this checklist, it probably looks very familiar if you can see the screen, of something that you might have learned in your first chart drawing math class. Is the title descriptive? Is there a summary? Is the chart type the right one? Does it use plain language? Are the axes labeled? Is the data labeled? Are the numbers formatted? Is the raw data provided? So what we're going to do is I have just grabbed some data and chucked it into Google Sheets and created a chart. And I wanted to show that the chart that is kind of the default in Google Sheets is actually not very accessible to begin with. It's pretty good, but it's got some issues. So let's start with the default chart, and then we'll work to make improvements along the way. All right, so here is a chart. First thing is the title descriptive? With disability, severe or profound, with disability, other status, and without disability. So Google Sheets grabs all of the column titles and just chucks them into the title. Most folks will obviously fix that. So let's fix that one up a little bit so that we give all the information that is useful. So this is actually a chart on Australians with disability from the Australian Bureau of Statistics data in 2018. This is not the best title, but it's good enough for now. All right, is there a summary? So what do we want people to take away from this chart? So this was actually included with the data where I got the raw data from. But kind of one of the big takeaways or one of the big kind of conclusions from this chart is 50% of Australians over 65 will have some form of disability, 50 to 20% with severe disability. Yeah, you can't really get that from the chart too easily if you can see the chart. And I always love projectors showing color contrast issues. You can barely read that, though this is a very nice projector. I'm surprised that you can actually read that grey bit. Is the chart type suitable? So this chart type is the default one that Google picked. I usually just like to try a few different chart types and see which one works best. You folks probably have a lot more deeper knowledge on like continuous data, discrete data, whatnot, and what chart to use. But I just kind of click around and pick one that supports my claim or makes the data really, really useful or obvious. So now we've picked a 100% stack chart. And it's immediately a lot more clearer that disability rates go up over the age groups. All right, does this chart use plain language? There's not too much language in this chart, but plain language is actually preferred by folks who might be specialists in a particular field, but using plain language and maybe like at a 9th grade reading level is actually preferred by everyone because it's less cognitive load to understand. So there's not too much to change, but I thought I might update the legend to be a bit less wordy. So no disability, with disability, and with severe disability. But yeah, that's probably that step done. Are the axes labeled? This is our favorite. So yes, the axes are labeled here, and we've got percentages on the side. We probably could add an extra label on the left, on the y-axis to make it really, really obvious what things are so that people don't have to think about, oh, this is a number of people or percentage of people. But we've got pretty good labels there. So the axes are labeled. Is the data labeled? We do have a legend in there, but we can go one better and put the labels right next to the data or right next to where most of the data is, so that you don't have to kind of do the matching by yourself. And also we'll come to talking about color in the next section. Oof, that is fast. We'll come to talking about color in the next section, where we'll make some improvements to this as well. All right, are the numbers formatted? In this case, yes, but this is talking about things like making numbers easier to read. So if you have large numbers, you want to make sure that there are commas in between separating thousands and hundred thousands and so millions and so on. So making sure that it's really, really clear. So the numbers here are formatted because there's not too many large numbers here. And this is kind of the catch-all. As much as possible, include a download of the raw data, because in case you haven't met everyone's access needs, they can just download the CSV and open it in their preferred app, which might be Excel. Excel is pretty good accessibility, and they can assess the data themselves. So yeah, making sure we include the raw data or including it in an accessible table on your website somewhere is great as well. All right, so a bit of before and after. Before content testing, after content testing, things are improving quite a lot, but we still have a little bit of fixes to make. So visual testing checklist. So this is kind of more related to more common concept you might have heard of in accessibility. So is there good contrast? So people who have low vision can read it. Is the text big enough? We don't want to make people strain. Is it using sans serif font or like a plain font? So Times New Roman is serif, Arial is sans serif. So fancy ligatures are not so inclusive of folks who might have dyslexia. And a big one in charts is, does it rely on color? And a few ones that we won't show today, but does it support magnification? Folks with low vision often use zooming apps, so they want to zoom into the chart. And no flashing animations, making sure that animations don't autoplay. This helps be more inclusive of folks who might be prone to seizures, so really important that we don't have flashing animations. And animations that autoplay, make sure that they can be stopped, more inclusive of folks who might have cognitive disabilities as well. All right, so good contrast. This projector is actually too good because it's really quite clear on there, but here is a tool I use called TPGI's Color Contrast Analyzer. And I really like to show the process because kind of a lot of blog posts will give a tool and say, hey, go and use this, but not actually show how it's used. I find that doesn't really help people a whole lot because you have to go and work out this random tool. And what we need to make sure of here is that the text is at least 4.5 to 1 contrast ratio. And other things like large text and components should be 3 to 1 contrast ratio. So the summary text is 2.8 to 1, which is firstly not compliant, but secondly not very accessible. All right, so now we've just darkened the text a little bit. The accessibility is a bit better. Is the text big enough? Let's bump it up there. Is there good contrast of non-text elements? So we're talking about now the data. So the yellow, red, and blue. Let's give that a test with the color contrast analyzer. And so we want this to be 3 to 1 ratio, which is quite small on the screen, but if you can see it, the yellow is 1.7 to 1, which is breaking the 3 to 1 minimum. But the other colors are good, 3.6, and I think the other one was 3.8. But let's pick a better color for the yellow, and we'll turn it into an orange. So that is a bit clearer and is accessible to folks who might have low vision. All right, cool. Color vision deficiencies or color blindness. So there is a tool called Color Oracle that you can use to simulate different types of color vision deficiencies. Red-green color blindness is a popular one, and testing grayscale as well, so that you can see if the colors that you're using for your data viz or your chart are going to work together and be recognizable by folks with various color vision discrepancies. It's quite good, but in grayscale it all got merged together. So we have a trick that we can do instead of trying to pick colors that are all high contrast to each other, which is pretty much impossible after 3 colors. We can use something else, which is by separating the colors from each other. So it does not rely on color. Let's not rely on color anymore. So yep, we're testing with the grayscale again, cool. We can't Really, if you can see that, you can kind of like tell, but it's quite subtle. We can add just some lines in there to split it apart, and now it's really obvious. So now we're no longer relying on color, and we can go one better and move those labels to the appropriate data series that they refer to make it really, really easy for people to not have to think too much and go, okay, these are what these data series are. All right. So before and after, before visual testing, we got, some nice yellow. After, fonts a bit bigger, fonts a bit darker, and we have separated the data series with a white line to make sure that we don't just rely on the color, we can rely on kind of their position in 2D space. And just a little bit of extra if we want to, make it really easy so that people don't have to match stuff up with the legend. Awesome, all right. So, quick one on using patterns. So, recommended best practice in the past that use pattern fills and dashed or dotted lines. If you're, like, for example, making a chart in grayscale, when you were in class, using like a pencil to make a chart, can't we just use patterns so we don't rely on color? Quick exercise, how quickly, if you can see the screen, how quickly can you match the following data series to their country? Yeah, it's pretty tough. So actually, patterns can actually make your accessibility worse because they can cause confusion. It's very confusing and very difficult to work with, where how quickly can you match the following data series now? And we added some numbers on there too to just make it, this really should just be a table. But yeah, so patterns, use with care. You can still use them if you like, but make them nice and subtle. And that's based on research done by a company called HighCharts, who build a great charting library. All right, lucky last, non-visual testing checklist. So does this image have alternative text? So if you uploaded something to like social media, like Twitter, I can't call it Twitter anymore, what is it now, X, LinkedIn, there is actually a place that you can add alternative text to explain what your chart is. So I've added some alternative text here. A stacked bar chart showing percentage of Australians with no disability, and severe disabilities per age group. Percentage of disability increases with each age group, with 50% of Australians over 65 having some form of disability and 15 to 20% of Australians over 65 with severe disability. There is a few recommended ways to write alt text, but it purely depends on what you want to communicate to the person. And we've got a really nice template here, written by a colleague called Amy Cecil, that helps you to get started writing alt text for your charts. And what my favorite part about that is the reason for including the chart, because sometimes we kind of make the chart and then work out a use for it later. And this really helps us to understand what goal are we trying to achieve with this chart. Text is inclusion. So if there is a conclusion you want your audience to reach, state it in words. This is great saying by Cole Nussbaumer-Knaflic, who wrote a book, Storytelling with Data. Amazing book on kind of design or data visualization, if that's something you're interested in. And interactive testing checklist. So what if your chart is dynamic, like dashboards? We all love dashboards. Making it accessible is really hard. We don't have time for this. I mean, to talk about today, we need to make time for it if we're going to do it. Choose a good chart library. There are some that have highly recommended. HighCharts is one of them. They've been working with people with disabilities to make sure that stuff works. This is the equivalent article that I wrote last year. That is this talk, and then all the interactive testing instructions as well. If you're looking for something to help you with testing really comprehensively, my buddy Frank Lasky created what's called a WCAG for charts. If you haven't heard of WCAG, it's a standard for accessibility. This is like really comprehensive step-by-step, like testing of interactive and static charts. More resources. So yeah, the Data Viz Alley group created a GitHub with a bunch of resources. because there just wasn't any available in 2020. There were a few, but not many, so we've put them all together there, so feel free to have a gander. And takeaways. If you don't take anything else away today, please start to add alt text to your charts and include the CSV or the raw data. If you're going to do an interactive chart, use an accessible chart library. A lot of hard work's been put into there, and always include folks with disabilities in your process. That's me. Surprise animation.
Thank you, Larene.
Thank you so much.
That's right, yeah. If you want Larene's slides, you can scan away.